Okay. In this video, we're going to take a look at section 3.2 on compound statements and connectives. I was just recording this lesson, and I got about 20 minutes into the lesson, and then I noticed that my mic was on mute. So I was talking to myself for 20 minutes, but it's actually probably for the best because there was definitely some things I wanted to kind of edit. I felt like I didn't say that right. I had the windows open so you could hear car noises at the beginning. So maybe it's for the best that I'm starting over. But I'm feeling a little bit exasperated right now. So, all right, let's just get into it. In section 3.1, we introduced the concept of logic statements. What we didn't describe those statements as were simple logic statements. So what we looked at in 3.1 can be classified as simple logic statements because they were just a simple, direct statement that would either be true or false. That's what makes them logic statements. So, for example, London is the capital of England. That was an example I can remember we talked about from section 3.1. That is a simple statement. In this section, we're going to be looking at compound statements. And there are different various ways of constructing a compound statement that has different logical meanings. And these compound statements will also either register as true or false, depending on how they're connected. But a compound statement combines two or more simple statements. The connection can vary depending on what words are being used. The four cases we're going to be looking at in this section are and, or, if then, and if and only if. Right, so those would be the four different ways we can connect two simple statements together into a compound statement. Okay. All right. Okay, so let's go and take a look at the first type. These are and statements. So I'll just go ahead and read what's on the notes, and then I'll try to expound on it. If P and Q are two simple statements, then the compound statement P and Q, now it's a little bit confusing because it looks like we just said the same thing over here, but we're just kind of listing these two statements individually here. With the quotes around it, we're joining those two statements together into a compound statement, P and Q. And P and Q can be symbolized in this way. And so the word and gets translated to this symbol, which is very closely associated with the intersection symbol that we saw in chapter 2. It really kind of logically has the same meaning. It's just for sets, we use the intersection symbol. For logic statements, we use this more like rigid V shape, which looks like a caret shape to me. The symbol I know as the caret symbol, which is on your keyboard. It's Shift 6 if you want to see it on your keyboard. All right. The compound statement formed by connecting statements with the word and is called a conjunction. So again, that's not usually a term I use very often. The symbol for and is this caret symbol here, so which I just tried to point out with this sloppily drawn arrow. It's right there. I didn't realize it was going to be stated so clearly in the next statement. What is not really being talked about here, and maybe will be relevant later in the lesson, is how do you know when an and statement is true? And we have to look at the individual simple statements to decide if the compound statement as a whole is true or false. So we'll look at an example here, and then we'll talk about how we determine if it's true or false. All right. So let's take a look at this example. Sorry, I'm having trouble talking. It's late. I'm tired, and I'm having to record this for the second time tonight. Okay. Let P and Q represent the following simple statements. P is the statement that it is after 5 p.m. Q is the statement they are working. It's kind of a weird collection of statements there. Write each compound statement below in symbolic form. The notes are kind of doing this for us here. The first example is it's a compound statement, so we're going to read it all together. It is after 5 p.m. and they are working. So that is the compound statement, but we can break it down into its simple components. The first simple statement here is, it is after 5 p.m. That is statement P, so we can represent that statement with the letter P. And is represented by this caret symbol here. They are working is literally statement Q, so we can represent that with the letter Q. And so we end up getting this symbolic representation of that statement. The way you would read this symbolically is P and Q. So that symbol is just translated to the word and. This example is a little bit different, even though the statements are pretty similar. It is after 5 p.m. Again, that is just statement P, so we can just translate that to the letter P. We can let P represent that statement. And, again, is represented with this symbol here. Try to draw that arrow again. There we go. But this time, it says they are not working, right? So they are working, that part of it translates to the letter Q. I'll try that again one more time. Okay, what happened there? Okay. But we're negating that statement, right? There's the word not in here. So we are negating the statement of Q. And if you'll remember from section 3.1, the way we negate a statement is with the little squiggly line in front of it. And so this will translate symbolically to this. The way we would read that is P and not Q. That would be the symbolic translation. Okay, so the statement is they are working or they are not working. I'm going to switch it up to I. So I am working. So this first statement here, it is after 5 p.m. This is true for me right now. Now, it might not be true for you while you're watching this video, but it is currently about 9 o'clock in the evening for me. And so this is true. It is after 5 p.m. And I am working, right? I'm making this video. This is, I'm not doing this for fun. This is work. And so that is also true. And for an and statement to be true, so we're looking at the individual statements. The individual ones are true, but what I want to know is overall, is the compound statement true or false? So I want to draw a single conclusion about the compound statement as a whole. And for the word and, we conclude that it is true as long as both of the simple individual statements are true. And since they're both true in this case, the compound statement as a whole is true. Let me try that again. The compound statement as a whole is true. The analogy that I might have given in class already when we talked about sets is for the word and. I just want to make sure that my mic is still working, actually. Okay, it's still working. For the and statement, it's like hamburger and French fries. So imagine a customer placing an order at a restaurant, and they order hamburger and French fries. The only way to satisfy that order is to put on their tray a hamburger and French fries. You have to get both. You have to get the first part of the order correct and the second part of the order correct to satisfy that order. You have to get the hamburger and the French fries. And so that's why we have to have both of these be true. I have to get the hamburger and I have to get the French fries for this order to be satisfied. This one, it is after 5 p.m. That is true. It is after 5 p.m. Sorry, I'll try to write that a little bit better. I am not working. That is false. I am working right now, right? So I got the hamburger. I didn't get the French fries. So on my tray, I got the hamburger, but they either didn't put a second food item or it was something other than what I ordered, right? They put a milkshake. I always go to milkshake for some reason. So they put a milkshake on the tray instead. So they didn't satisfy my order, right? If I ordered hamburger and French fries and on my tray, I get the hamburger, but I don't get the French fries, I get something else, then my order was not satisfied. And so this would be false. Right? So that's how and works logically. And I'm hoping that's something that we'll be talking about later. So I just want to kind of set that up for later. Okay. The next statement we want to look at, I'm sorry, I'm jumping ahead a little bit too much here. These are equivalent ways of saying the same thing. Excuse me. So on the homework, they might word things slightly differently. So you might want to have this table handy. So when they use slightly different wording, you can look on this table to see, does that mean the same thing as and? So all of these mean the same thing. They all mean the same thing as and. So we could say P but Q. So for example, it is after 5 p.m., but they are still working. Again, we're saying both are the case, right? We're putting both of those statements out there together. So it's an and, right? We're saying it is after 5 p.m. and they are working, even when we use the word but. Yet means kind of the same thing as but, right? So it is after 5 p.m., yet they are still working. We're asserting both. So it's an and. P, nevertheless, Q, that one's a little bit unusual, flowery wording that most people probably don't use, but it means the same thing as and as well. It is after 5 p.m., nevertheless, they are working. So again, both statements are being asserted there. Okay, let's take a look at or examples. So I'll just kind of read through the notes with you and then we'll kind of talk about it. Let me make sure I'm lining things up so it's all still in the video. It looks like I am. Okay. The connective or can mean two different things. So consider the statement, I visited London or Paris. I'm saying that funny. I visited London or Paris. I don't know how much I really like this example. I feel like a better example is, I think about like, let's say, remember when you were a kid, right? And your parents take you to the store, and they tell you that you can buy something at the store. And so but they might want to limit your choices, right? So they might say, okay, we're going to the store. You can buy candy or a soda, right? They're going to let you buy something and they tell you, hey, you can buy a candy or soda. Now, when your parent tells you that, you know what they mean is that you have to pick one or the other. Either you're going to get candy or you're going to get soda, but you cannot have both. That is an example of the exclusive or. Exclusive means just one or the other, right? So if somebody tells us, I visited London or Paris, we probably interpret it the same way. That they're saying they visited somewhere, maybe they can't quite remember which city it was, but we probably assume they just mean one or the other, right? Just like when our parents say, you can buy candy or soda, we know they just mean pick one or the other, you're not getting both. So that's called the exclusive or, which is probably the most common way or is used. I feel like when I think of examples of how we use or, we usually mean it in the same way. However, in math, we actually don't mean it quite that way. We mean the other version of the word or, which is called the inclusive or. So this would be if your parents or, whoever's taking you shopping tells you you can buy candy or soda, but they also would be okay if you picked both, right? Again, I can't imagine either of my parents being like that. But trying to think of a good example where the or could be inclusive. Again, this is the example I always give in my algebra class. I go back to the hamburger and French fries. I'm eating better now than I used to, but I'm still a sucker for hamburger and French fries, and I usually have it about once a week, probably. So an example that I think of, let's say my friend, we're hanging out, we're playing video games or whatever, and my friend decides, I'm kind of hungry, I'm going to run and get a snack. I'm going to go to McDonald's or whatever, right? And I'm not going to go with my friend, but my friend, is being nice, and he or she says, do you want me to get anything for you at McDonald's? I'll bring it back. I'm going to go get something to eat. I'll bring something back for you if you want something. And let's say I kind of do want a snack. And so I tell my friend, sure, give me a hamburger or French fries, one or the other, give me a hamburger or French fries. So if my friend goes to McDonald's and they come back and they give me the hamburger, okay, I'm going to be happy. I said, give me a hamburger or French fries. I'm letting my friend make the choice, right? And they bring me back the hamburger. I'm good with that. If they just bring me back the French fries, of course, I'm going to be good with that. But they could also say, I wasn't sure which one you wanted, so I got you both. And I'm not going to be upset about that either, right? So that'd be the inclusive or. Hey, give me hamburger or French fries. And if you got me both, I wouldn't be upset about that either, right? So that's the inclusive or. The inclusive or means one or the other or both would be okay. And that is the way or gets used in logic, at least unless it's otherwise stated, right? So if you see the word or in logic, you should assume it's the inclusive or. The exclusive or, I don't know how they would denote that otherwise, but in this class, it's always the inclusive or. Disjunction is a compound statement formed using the inclusive or. So again, we're using the inclusive version of the word or. And we represent the inclusive version of the word or with this symbol here, which is just the flipped over version of the symbol for and. It's also very closely, strikingly similar to the union symbol that we talked about for sets. And it logically has the same kind of meaning. So there's a reason why they look so similar. So the statement of P or Q or both can be represented symbolically like this. And we would still read it kind of the same way, P or Q. We wouldn't say the or both part, at least I don't. But it's implied because we're always talking about the inclusive or when we use the word or in math. All right. So here we're being asked to translate these symbols into symbolic form. So statement P is the statement, the bill receives majority approval. The first time I recorded this video, I started off saying the bills receive. And I made the joke that when I see the word bill, I just think of bills that I have to pay, right? And it's always plural because there's always many, many bills, right? But this is not talking about bills that you pay. This is talking about a bill in government, right? So a bill that the House of Representatives, like just recently, the House of Representatives passed a spending bill to avoid the government shutdown, right? So that's the kind of bill we're talking about here. The bill receives majority approval. That's statement Q. Sorry, I said the wrong letter. That's statement P. Statement Q is the bill becomes a law. All right, so write each of these compound statements using symbolic form. So the bill receives majority approval. That is literally just statement P. So I'll put P there to represent that statement. Or is represented by this symbol here. Let's try that again. All right, and I'm saying and, but it's an or there. But the last part of it, the bill becomes a law. That is statement Q, so we can let Q represent that. And so symbolically, we can represent that compound statement like this. And we would read it as P or Q. And again, we mean that both could be the case. The bill receives majority approval, or the bill becomes a law, or both might be true. Right? Excuse me. Okay. The bill receives majority approval. That is, again, statement P. So we're going to represent that with the letter P. Or we represent with this symbol here. And this one is the bill does not become law, right? So the bill becomes a law is statement Q, but we are negating that statement, so we need to put the squiggly line in front of it, and we get this symbolic representation here, which would be read as P or not Q. All right, let's take a look at the next page. The next type of statement that we are going to consider are the if-then statements. All right, so this diagram shows a relationship that can be expressed in three ways. All poets are writers. We actually considered this statement in section 3.1. This is one of the quantifiers, right? All, some, or none. Here we're using the word all. All poets are writers. I didn't quite show this in class on Monday, but it's in the notes for section 3.1 that this would be represented in a Venn diagram this way. Since all poets are writers, the circle representing poets has to be within the circle representing writers, since all poets are writers. So anybody that's in this set has to also be in this set. And the only way to guarantee that in a Venn diagram is for this circle to be inside of this circle, which is what you're seeing over here, right? So all poets are writers. So anybody in the circle for poets will automatically be in the circle for writers because we set it up this way. But we also have some extra space here inside the circle for writers, for writers that are not poets, like playwrights, journalists, authors that, like write novels, things like that, right? Those people would be writers, but they would not necessarily be poets. So they'd be kind of in this space right here. Anyways, we could also say the same thing, and we talked about this in 3.1 as well. There are no poets that are not writers. Right? We could say that, and it means the same thing. It just means all poets are writers. Just I don't like it because it's the double negative. Hopefully we don't see that one too much. But what we didn't talk about, because we hadn't talked about compound statements yet, we could say that same thing in this way. We could say, if a person is a poet, then that person is a writer. So anybody who's a poet is a writer. If a person is a poet, then that person is also a writer. And so that is an if-then statement. And it's composed of two simple logic statements, right? A person is a poet, right? That could be statement P. A person is a writer could be statement Q, right? And so we're getting if P, then Q. And even though it's not like joining them together like and or does, it's still a compound statement because it's a statement that involves two simple logic statements, right? It's a bigger statement involving two simple statements. Okay, so let's take a look at what the notes say down here. The compound statement, if P then Q, is symbolized using this arrow symbol, right? And the arrow goes just in one direction. It goes to the right is the way that needs to be drawn. So, and we would read this as if P then Q. That's how you translate that symbol. This is called a conditional statement, right? So we talked about ands are conjunctions, ors are disjunctions, if-thens are conditional statements. The statement before the arrow, which is P in this case, is called the antecedent. And the statement after the arrow, which is the Q in this case, is called the consequent. Right? So if-then statements always look like this. And hopefully we won't need to know those words afterwards, because I never use those words. I hope they don't really make you use them on the homework, but there are names for them. So let's look at an example. If P and Q represent the following simple statements. P is the statement that a person is a father, and Q is the statement that a person is a male. Okay, so write each compound statement. Now I just want to say, I'm just following the notes, and I'm sure this example is probably taken from the textbook. So I don't want to get into gender politics or identity politics or anything. I just want to say that this example does not reflect my personal views necessarily. I'm just using the example that I was provided. So we have the statement, and again, we're not saying whether this is true or false either, right? So, I mean, these statements can be considered, like, they're supposed to be something we can evaluate as either true or false, but we're not doing that here. So hopefully I'm not upsetting anybody, and if I am, I apologize. I don't mean any offense. Okay. If a person is a father, then that person is a male, right? So that's our example A. We want to translate that symbolically. So a person is a father, right? Translates to the letter P, right? P represents that statement, so we can let P represent a person as a father, because up here that's what we're told statement P is. That a person is a male is statement Q, so we can represent that with the letter Q. And then the if-then part of this, the if-then part is represented by this arrow here. And so symbolically, we could represent that this way, P with the right arrow and then Q, but we would read that as if P, then Q. All right, let's take a look at the next page. All right. Example number 2, if a person is not a male, then that person is not a father. All right. So we want to translate this symbolically. Okay, so if a person is not a male, so again, a person being a male is statement Q, but we are negating that statement, so we need to use the squiggly line in front of that, right? Then that person is not a father. So a person being a father is statement P. But again, we are negating that statement, so we need a squiggly line in front of that one as well. The if-then part of this translates to the arrow here, and so we end up getting this. And so we would read this as if not Q, then not P. That's how that would be read. All right. Here are some other ways of saying if P, then Q. All right. So let's go ahead and scroll down and take a look at these. All right. So again, the most straightforward way, the way I'd prefer, because I like to keep things simple and just kind of do it the same way every time. If a person is a father, then that person is a male. That's if P, then Q. But it's logically equivalent to say a person is a male if that person is a father. And that symbolically would be if, sorry, I'm saying it wrong, Q if P, right? So notice the if is still with P there. It's just kind of written backwards, written in the reverse order. These are kind of strange here, so you might want to keep this table handy just in case that wording gets used in any of the homework problems. You can look it up here and figure out what that translates to, and you'd want to kind of translate it back to this basic statement here. So if in the homework you see a statement that says something like this, being a father is sufficient for being a male, right? That's kind of hard to wrap your mind around, so you might look at this table and say, oh, is sufficient for, that translates back to if P, then Q. And it kind of goes in the order, right? So this would be P, this would be Q right here. So if I see the word sufficient, I'm going to say if this thing, then this thing over here, right? If P, then Q. All right. You could also say it this way. Q is necessary for P. That means the same thing as if P, then Q. So if I see the word necessary, I'm going to look it up on this chart and say, okay, this is equivalent to if P, then Q, but this one's backwards. The first thing is actually Q. The second thing is actually P. So when I go to rewrite this in the more basic way, I would have to say if the second thing, then the first thing, if they're using the word necessary there. We could also say P only if Q. A person is a father only if that person is a male. That means the same thing as if P, then Q. Only if Q, P. Only if a person is male is that person a father. That means the same thing as if a person is a father, then that person is a male, right? So these are just all different ways of saying the same thing. And your best bet is if you see any of these alternate phrasings, just translate them back to the basic one, the first one here. That's what I would do. All right. The last compound statement that we want to talk about, the last type, is the if and only if statements. So when you kind of look at these jumble of words here, it might be kind of hard to disentangle what is being stated here, but this kind of goes together as a block, right? So if and only if statements are what we're looking at, or what we are looking at here. All right. Biconditional statements are conditional statements that are true if the statement is still true when the antecedent and the consequent are reversed. So again, they're using that fancy language there. So we were just talking about the statement if P, then Q. If you reverse P and Q, right? So we're talking about this statement, if P, then Q. If you reverse the P and the Q and you say if Q, then P, that might not necessarily be true. So if this is true, the first one, the second one may not still be true. So it's not commutative, if you will, right? You can't just move the order around and have it still mean the same thing. All right, so we have to evaluate it first before we accept the second one as being true. And that's what we're talking about here. And that's what we mean by flipping the antecedent and the consequent. So if you flip P and Q, and it's still true after you flip it, then that's called a biconditional statement. It's a special kind of statement, because that isn't always going to be the case. And so that's the point they're trying to make here. If a person is a father, then that person is a male. That's being considered true here. If you flip that around and you say, if a person is a male, then that person is a father, that is not necessarily true, right? You can be a male and not be a father. to be a father, you have to have a child, right? So if a person is a male, that doesn't automatically guarantee that they will also be a father. So that second statement is false, right? It doesn't have to be true for every male. So we have to consider that to be a false statement. So this is not biconditional. It's only true in one direction. It's not true in the other direction, right? So this direction is true. This direction is not true, right? This direction is false, right? So it's not biconditional. All right. However, for this example, if a person is an unmarried male, then that person is a bachelor, right? That is being considered true here. If a person is a bachelor, by definition, that person is an unmarried male, right? That's what bachelor is supposed to mean. And so that would also be true. So this one, it's true in both directions, right? So let me switch colors here. It's true in this direction. If P, then Q. It's also true in this direction. Oops, why am I putting another arrow there? Getting carried away. It's also true in that direction. So that one is biconditional. And if it's biconditional, we can put both of these together. So what we can do is join both statements together into one compound statement. Sorry, that kind of went off track there. Right here. By saying this, P if and only if Q. This means both. It means P, if P then Q. It also means if Q then P. It means both of those things. And we can put both of those together using the bidirectional arrow. Right, so like this, right, which is, it's right there, but I covered it up, so I wrote it again. Right. Okay. And we also can abbreviate if and only if as IFF, because again, mathematicians are lazy. We don't like to write out a lot of words. And so I can remember in graduate school taking math classes, and you do a lot of proofs and stuff like that. And a lot of proofs were, prove that blank if and only if blank. And I hated those proofs because you had to prove two things. You had to prove if P is true, then Q is true. And you also had to prove that if Q is true, then P is true. You had to so if they ask you to prove if P, I'm saying this wrong, if they ask you to prove P if and only if Q, you had to prove two different statements. It was basically two problems in one, right? So it was always a lot of extra work. So I remember that statement very well from my time as a student. Okay, so here are alternate ways of saying the same thing. All right, let's make sure this is still in the window here. Okay, good. Sorry, it's a little blurry for some reason. So P if and only if Q, that means the same thing as Q if and only if P, because again, it's true in both directions, so it doesn't matter which one goes first and which one goes second. So in the case where it's bidirectional, it is commutative. The order doesn't matter, right? If P then Q, and if Q then P, so which we just talked about, right? If you use the word if and only, if you use that phrase, then both are true, right? If P then Q and if Q then P are both true. All right. P is necessary and sufficient for Q. Means the same thing as P if and only if Q. So if you see both necessary and sufficient, that translates to this, right? So again, I wouldn't leave it in those words. If I see those words on a homework problem, I'm going to use this chart. I'm going to see, oh, I have both necessary and sufficient. I should translate it back to this basic form. P if and only if Q. Q is necessary and sufficient for P. So again, the order doesn't matter. You can flip the order around. Okay. Okay, so here we have a summary of all the different forms that we have talked about so far. So we have the negation of a statement, which we talked about in 3.1. We have conjunctions, which are ands. We have disjunctions, which are ors. Again, I don't usually like to talk about the official terminology. We have the one directional arrow, which is a conditional statement and is if P then Q. And we have the bidirectional arrow, which is the biconditional statement of P if and only if Q. Right. So those are the basic types that you need to know from section 3.2. All right. Now I'm getting into some new territory here because I kind of talked about most of that stuff in my previous attempt at recording this video. And so now this will be kind of new for me, so I might kind of stutter and stumble here a little bit, and I apologize. Okay, so let's look at some examples. Let P and Q represent the following simple statements. The statement P is, she is wealthy. The statement Q is, she is happy. Write each of the following symbolic statements in words. Oh, great. So this is going to be kind of hard for me to do. So I'm using this writing tablet at home, but it's just like writing on a table. Like and it's like writing with a stick or something, right? So I can't see what I'm actually writing directly on my tablet. I can only see it as it shows up on the screen. And so it doesn't come out very neat. So I will do my best here. So this one, example A, I would start with the innermost parentheses. So we're going to negate this thing. But before we try to negate it, let's just kind of figure out what's going on inside the parentheses. So remember, this symbol is the and symbol, right? And so we're going to translate this as statement P is, she is wealthy. So sorry. Maybe I might just pause the recording so you don't have to be tortured by watching me slowly try to write out these letters. This symbol is and, so we're going to put and there. And then statement Q is, she is happy. Okay. So that is the part that's inside the parentheses, right? She is wealthy and she is happy. We want to negate that. So what we could do to negate this is remember we talked about this in 3.1, kind of the cheap way, which I kind of feel like, that's not really the cheap way, but I feel like it's the safe way to negate this one, because negating compound statements is tricky. It's not as simple as just throwing in a not somewhere. It does weird things, right? So what I want to put here to kind of figure out a better wording, so I'm going to try to do a better wording after this, but we talked about this in 3.1. To negate a statement, you can always just throw it is not the case that. It is not the case that she is wealthy, and maybe even put some parentheses around this. She is wealthy and she is happy, right? Let me make sure that that's in the video here. Okay. Oh yeah, we're good. Okay. So to negate that, we could say it is not the case that she is wealthy and she is happy. And I assume this is going to be multiple choice on the homework, so maybe that's good enough. Maybe there's a statement that looks very similar to that on the homework. If you want to apply that negation to the individual statements, and you want to say she is not wealthy and she is not happy, it wouldn't be an and anymore, right? So what's going to happen is, because the compound statement is saying she's both, right? Because remember, and both have to be true. You have to get the hamburger and the French fries. So for this statement to be true, she has to be both wealthy and happy. And negating that means we just have to get one of those wrong. Meaning the negation of that is that either she's not wealthy or she is not happy, right? She could still be one of these and we could still negate it that way, right? So again, we could mess up the order by giving them the hamburger but not the French fries, or by not giving them the hamburger and giving them the French fries, and it's still messing it up, right? So we only have to take away one of these to mess this thing up. So if you want to say it in more informal language, what we would have to say is that either she is not wealthy or she is not happy. Or it could be both, because again, the word or in this context is the inclusive or. Maybe she's not wealthy and not happy, but she doesn't have to be not wealthy and not happy to negate that statement. She only has to miss on one mark. She doesn't have to miss on both marks, if that makes sense. So because she only has to miss on one mark, we want to use the word or here, right? So she is not wealthy or she is not happy would be how you would negate the statement she is wealthy and she is happy. We just have to take away one of those things. All right. And because it only has to be one, we use the word or. Okay. So this would be another way of saying the same thing. But again, it's kind of tricky to figure that out. So this is the safe way, right? So try this first. I think that's also just a good starting point, because for me, I wasn't ready to jump to this second statement. I needed to think about it for a minute. So I wanted to write it out in a safe way first and then kind of think through what that really means. But for multiple choice, if it's on the homework, if I assume it's multiple choice, you're going to have to kind of just go with the wording that they present to you. So you have to kind of think it through carefully. All right. Now, statement B is actually, I think, easier than statement A. So let's go ahead and do B. I'm just running out of room here. So let's just do this right here. And then we'll do C below that. I don't think we're going to have to rewrite this one. We want not P and, because again, that's an and statement, Q. So not negating P, that's simple. You just throw a not in there, right? We could say it is the case she is not wealthy, but we're not thinking like this doesn't apply to the happiness one, right? That negation only applies to P. It doesn't apply to both statements like A did, right? In A, that negation applies to both P and Q. Here, we're only applying the negation to P. And it's just like we did in 3.1. To negate that, we could say it is not the case that she is wealthy, but it's just easier to say she is not wealthy, right? So to negate statement P, we would say she is not wealthy. And then and, right, because that's the and symbol, she is happy. All right. Right. So she is not wealthy and she is happy. And there's no need to like translate that any further. That's pretty plain language there. And there's really just no other way to really write that in another way. So that's it. That one kind of translates pretty directly without any confusion. So really, I guess your red flag here will be if they have a negation with parentheses. That's when things get really tricky and you have to be very careful about how you translate what that means. And so that's happening again in part C, right? We have a parentheses here and we're negating that entire parentheses. So that's going to make this kind of challenging to figure out the plain language meaning of it. We could do the same thing we did up here. We can translate just as a safe thing to do first. Translate the negation as it is not the case that. It is not the case that. And then we'll put the compound statement after that. And again, that kind of all goes together. I put parentheses here. I'm trying to think of a better way we could have done that. I'll just do the same thing here, I guess. It is not the case that P, which is she is wealthy, and this one is an or, right? That's the flip version. I want to say flipped upside down version, but that maybe was a little bit redundant. It's the upside down version of the and one. So this is the or. So or she is happy. Okay. Okay. So it is not the case that she is wealthy or she is happy. So what this is saying is she's not either one, right? It is not the case that she is wealthy. It is also not the case that she is happy. And it's also not the case that she is both, right? Because again, we're using the inclusive or. The inside the parentheses part is she is wealthy or she is happy or both. But we're negating that. So we're saying it's not, because or means any one of those would be good, right? If you got the hamburger, you would be happy, right? Because if you're saying I want hamburger or French fries, if you got just the hamburger, your order is satisfied, right? If you got just the French fries. So if she's wealthy, that's a true statement, right? Doesn't matter if she's happy or not. She got the hamburger, right? So she's wealthy. If she is happy, it doesn't matter if she's wealthy or not. Or she could be both, and that would be okay too. We're negating all of that, right? So it would be like your friend asking you, do you want a snack from McDonald's? And you say, sure, give me a hamburger or French fries. And then they go and they come back with McNuggets. And you're not going to be happy about that, right? Because they didn't give you either one. You said hamburger or French fries, and they got you something completely different. So no hamburger and no French fries means you're unhappy in that case. So even when you use the word or, that's a pretty relaxed word, but you can still fail at that, right? You can still not satisfy that request by, as the example I just gave, if I ask for hamburger or French fries and I'm brought McNuggets, then I might be like, hey, that's not what I asked for. I might be unhappy. Maybe I don't like chicken McNuggets, or maybe I'm allergic to chicken or something like that, right? So I don't know why I'm going off on a tangent a little bit too much there. I apologize. The point is, for me to be unhappy with that request, I would have to get not the hamburger and not the French fries, right? In order for my request to not be satisfied. I don't want to make it sound like I'm a picky, demanding. I'm not high maintenance or anything like that at all. I would be cool with McNuggets as well. But just logically speaking, that would not satisfy the request that I made, right? But the way you would not, so if I asked for hamburger or French fries, the way you would not satisfy that would be to not get me the hamburger and not get me the French fries. So that I'm trying to emphasize the word "and" there. So when you put these two together, this becomes she is not wealthy and she is not happy. You would have to not get either one of these, right? And it would have to be an "and" because you have to get both of these right. If you only get the not wealthy, but she's still happy, then you didn't negate it, right? Because you're saying she's either wealthy or happy. She's one or the other of those things, or both, right? So if you take away the not wealthy, if you take away the wealthy and say not wealthy, but you leave the happy, well, then she's still one of those things. So you didn't negate it. It's only negated if you take away both of these things, right? So we have to say she is not wealthy and she is not happy. We have to take away both, which is why we have to use the word "and." She is not happy. All right. And that would be the equivalent way of saying that. And the better way to say it, right? That's the more, how do you say, natural way is probably a good word for me to use. It's the natural way we would say a statement. Because nobody talks like, it is not the case that this, right? The way we would naturally say that is, she is not wealthy and she is not happy. That's how we would negate that. Okay. I hope that makes sense. I know it's kind of hard to follow. If you think about it hard enough, it'll start to click, and maybe with a few more examples, that'll help too. Okay. If P and Q represent the following simple statements. Sorry, I need to take a drink for a second. Sorry about that. I'm drinking carbonated water, and sometimes it doesn't go down easy, so. Okay. Statement P is the heater is working. Statement Q is the house is cold. Write each of the following compound statements in symbolic form. So this should be easier for me to do with my writing tablet. The heater is not working, right? So again, the heater working is statement P, but we're negating that. So we're going to put a squiggly line in front of it. And so again, that is the upside down V shape. The house is cold. That is statement Q. It's not being negated, so we're just going to call that Q. And so symbolically, we would get this. Not P and Q. All right. The heater is working. That is statement P, so we can represent that with P. It's not being negated, so just P. Or is the V shape. The house is not cold, right? So the house being cold is statement Q, but we are negating that statement, so we have to throw a squiggly line in front of that, and we get this symbolic representation here. P or not Q is how you would read that symbolic representation. If the heater is not working, then the house is cold, right? So the heater working is statement P. We are negating that statement, so we want to put a squiggly line in front of that. The house is cold, that is statement Q. The if-then translates to the unidirectional arrow, so the one directional arrow. And so it would translate like this. And again, we would read this as if not P, then Q. All right. The last example here, the heater is working. That's statement P. If and only if the house is not cold, right? So again, the house being cold, that's statement Q, but we're negating statement Q, so we want to put a squiggly line in front of that. And the if and only if, let me use a different color here. The if and only if translates to the bidirectional arrow. All right, and so we get this. Okay, so we would read that as P, if and only if, not Q. Okay, and remember, that means if P, then not Q, and it also means if not Q, then P, right? It means both of those things. That's what the bidirectional arrow indicates. Okay, so let's see. This is the last page. Great. Okay, so we're almost done. Just a few more examples here. This is going to be hard to do. We want to write each of these symbolic statements in words. So again, I'm going to have to write this out in words. And I think we're supposed to use the example that we were just using, which is on the previous page. So you might just have to go back in your video. I think I can remember what the statements are. P is that the heater is working. Q is that the house is cold, right? Let me just double check to make sure I got that right. All right. Heater is working, house is cold. All right. So P is that the heater is working. Q is that the house is cold. So this would translate as P, the heater is working. This symbol is the and symbol, so we put and there. And then not Q would be that the house is not cold. And the house is not cold. Now I'm afraid this isn't showing up in the window of my video. Let's see. Oh, no, it is. Okay, we're good. Okay. The house is not cold. Now, usually the window for my video stays on the screen, but it keeps disappearing on me for some reason. So I'm kind of paranoid I'm not even recording what I'm doing, but I think it should be fine. It's done that before to me. But then I keep losing my recording area, so I don't know if I'm writing outside of it. So I have to kind of bring it back up every once in a while just to double check. The heater is working and the house is not cold, right? That's how that would translate. Okay, I'm not going to put a box around that. That would just make it look even messier. So this one is, again, this symbol is the if-then clause, right? So we're going to say if, and then we'll have to say then. So this is if Q, then P, right? So they flipped it around on us. Q is the house is cold, right? So if the house is cold, then P, then the heater is working. All right, now, you might be saying, wait a minute, that doesn't make any sense. If the house is cold, can't talk. If the house is cold, then that means the heater is not working, right? And you're absolutely right. This is false, right? So if-then statements can be true or false, right? This one's a false one, right? If the house is cold, then the heater is working is not true. That's false, right? But it's still a logic statement. It's a compound statement. It's just a false one. But it's the one they wanted us to write. So that's what we wrote. Okay, again, this one, gotta be careful because of the parentheses. So if you see parentheses, you gotta be on your toes with this, right? So I'm gonna do safe statement first, and then try to see if we can get a better natural statement of the same thing, right? So again, the safe statement is to translate the negation as it is not the case that. So it is not the case that, and then we want to negate the following thing. We have P or Q, right? So this is the or symbol here. So P is that the heater is working. So it is not the case that the heater is working. Sorry, I hope it's legible enough that you can translate it and you know what I'm trying to say. Or, because we have the or symbol there, the house is cold. There's no negation inside the parentheses, so we just put the statements. The house is cold. All right, now let me make sure that's still showing up in the recording area. Okay, it looks like it should be. Okay, so again, how would I write that in a more natural way? So it's an or. So this is actually very similar to the example that we did. I think it was up here. Right. It's very similar. It's actually basically the same thing as C. So to negate an or, it becomes an and. And so notice the pattern there, right? When we negated this and, it became an or. When you negate an or, it becomes an and. And when you switch it from or to and, the individual statements, the P and the Q, both become negated, right? So we're going to follow that same pattern in this example here, right? So to negate this statement, and I guess I should have closed the parentheses here on this end, so we'll put the end of the parentheses there. To negate that whole compound statement, it is not the case that the heater is working or the house is cold. In order to negate that, I don't want to go through the whole hamburger and french fries example again, but just briefly, you have to not get the hamburger and not get the french fries to not satisfy that request, right? So we have to have the case that the heater is not working. I guess I should use a capital T there. The heater is not working, right? We're going to negate that. And, right, it becomes an and, the house is not cold. All right, so when you negate, and only when there's parentheses, when you negate an entire or statement, it becomes an and statement with both P and Q negated. So if you want to write this symbolically, I was kind of avoiding this because it wasn't in the notes, but like it's kind of like a formula, right? This becomes not P and not Q. So it's kind of like, you can kind of think of it a little bit like you're distributing, right? This is kind of like a negative sign that you're distributing into the parentheses. It's going to hit both P and Q, but the symbol also has to get flipped around the other way, right? So you could write this in your notes and then just use this whenever it comes up in the homework, right? If you're negating parentheses, P or Q, that becomes not P and not Q. We can have a similar formula for this one, right? So if we are negating an and, that becomes not P or not Q, right? So again, it's like the symbol gets distributed, but the and flips to an or, right? And so that's how that one ends up translating, right? So feel free to use those formulas to translate those, right? Instead of having to logic your way through it. All right, we got one more example here, and then we are done. All right, so this one is an if and only if. So this one's gonna be pretty easy, I feel like. Not P. This is the heater is not working. If and only if, right? Because that's the bidirectional arrow means if and only if. And I'm tired. I'm ready to be done with this video. I'm sure you guys are ready to stop watching it. I'm going to use the abbreviation this time. If and only if, right? Not Q, right? Which means the house is not cold. If and only if the house is not cold. All right. And so that's how that one would translate into words. All right. Thank you for watching the video. I will see you for section 13.1 is the next section we're going to be doing.